So in this lesson, we kind of added this in here to help you remember how to simplify radicals. So a radical looks like this. Sometimes I call it a little house, but it's our radical symbol. Radicand is just the number that goes underneath. And then we're just going to look at square roots, not any other bigger roots, but remember that when you take the square root of something, you have to put a plus minus. If there's already a square root symbol in there, you don't need that. And ones that you cannot simplify would be like square root of 2, square root of 3, square root of 5. Those would not be able to simplify, like something that would be the square root of 25. That's a perfect square. So all of our perfect squares kind of listed those here, at least the first 15. 1, 4, 9, 16, 25, 36, 49, etc. that come out to be a rational number. So what we're going to be looking for is the biggest perfect square that would be in our number, and that perfect square can come out, and then anything that is not a perfect square, that's still a factor, would stay underneath. So here are a couple of examples done for you. If there's already a coefficient out front, we do multiply anything that comes out front with that. So let's go ahead and do a couple of examples together. There's a couple of, again, different ways you can do it. The first one is to find just factors of that number and then look for groups of 2, and that number can come out, and then the numbers that don't have groups of 2 have to stay home. Or to break it down with the biggest perfect square and take that out and leave that there. So if you're one who's not the best at coming up with a factor of something, you might want to just kind of break it down as all of the prime factors and then look for those groups. So I'll do it a couple of different ways. So for this first one, we can see that it's 4 times 2, pretty small number, easy to kind of break that down. 4 is a perfect square, so it gets to come out. The square root of 4 is 2, and then that 2 stays under. So in this next one, 50 is going to be 25 times 2. 25 gets to come out and be 5, and 2 stays home. Let's take a look at the next one, though, using kind of our prime factorization if we don't know how to break down 192. So what we can do is just start by kind of listing, well, 2 times, actually I'm going to go ahead and bring it up here so I'm not taking up my room, but 192. 2, I can go ahead and divide it in 2 because this number right here is even. So 2 times 96, and then I'm going to break down 96 because 2 can't be broken down, it's prime. And I can break that down again in half. And I can break that down again in half. And again in half. And again in half. And again in half. And now I'm done. So I have 2 times 2 times 2 times 2. So I have 1, 2, 3, 4, 5, 6 2's. And a 3. Okay. So I'm looking for groups of 2. There's 1, there's 2, there's 3. So a 2 gets to come out. There's that group. Another 2 gets to come out. Another 2 gets to come out. And the 3 has to stay home. And so 2 times 2 times 2 is 8. Square root 3. So if that is easier for you, it can take a little bit longer sometimes. You can do it that way and just break it down. But if you can try and get the biggest perfect square, so on this one, you would try and get 64 times 3. So again, we're looking for these numbers here that are perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81. And you're trying to find that as a factor of the number underneath the radical. So for 75, 25 times 3. 25 gets to come out as 5, 3 stays home. 18 would be 9 and 2. 9 gets to come out, 2 has to stay home. So if you can get the biggest perfect square, a lot of times it is bigger, or it's quicker. When it's bigger, like 320, a lot of people go for 4, and they would say, yay, 4 works. Well, you want to make sure you, again, get the biggest one, because if you take 320 and divide it by 4, you get 80, which still has a 4 in there. And so keep going until you kind of get the biggest one, which would be 64 and 5. And so 64 becomes 8 and 5 stays home. 300, we would get 100 times 3. And so the 100 gets to come out as a 10, and the 3 has to stay home. And then again, we multiply. If there's already a number out front, we multiply by what comes out. So 50 square root 3. So now we're going to take a look at multiplication here. Multiplication, we can multiply things that are the same radical. So both of these are square roots, so I can take 6 times 15, and then I'm going to simplify it. So square root of 90, and I can go ahead and pull the 9 out to be a 3, and the 10 stays home. 7 times 7 is 49. And isn't the square root of 49, that's a perfect square? 49 is. It just becomes 7. When it's a perfect square and it comes out, we do not have a radical anymore over it. For this next one, 2 times, well, this is not a radical, so it's just going to go next to or in front of, because it can't actually multiply underneath. Only radicands and radicands, or coefficients and coefficients, like that one. When something is squared, it means we have 2 of them. So I have 8 square root 2 times 8 square root 2. And so the 8s get to multiply, and the square root of 2 times the square root of 2 is square root of 4, which is a perfect square. So that becomes 2, and then we take 64 times 2, and that is going to get us 128. So try number 13, multiply those coefficients, multiply those radicands, simplify if you can. So 12 square root 6, and square root 6 cannot simplify, so you are done. The last thing we're going to talk about is if we have a radical in the denominator spot. We cannot have a radical divide by a radical, so we are going to do what's called rationalizing. And we are going to take the top and the bottom times that radical. So on the top, it's just 10 square root 2, because again, we cannot multiply those. So we put them next to each other. Radical 2, we can, which is the square root of 4, which is a perfect square. So that becomes 2. And now, that's exactly what I wanted to have happen, because now there's no longer a radical. Last step is to just look vertically and make sure there's nothing that can simplify, which it can on this one. 10 over 2 is a 5, and then we leave that radical 2 with it. So try number 15. Go ahead and multiply by, again, the radical in the denominator spot. And try it and see what you get. And hopefully you got 3 square root 10 over 2. Cannot simplify vertically, so we just leave it there.